So cumulative frequency curves are a way to find quartiles and medians when you have a lot of group data. So here, what we have is we have group data from 0 to 10, 10, 20, 20 to 30, and we have the frequency, so this kind of data we've dealt with before. On the chart that we've added here is a cumulative frequency. How many in total have you counted after going up to 20? Well, since there was 1 here and 4 here, we're at 5 in total. Then if you add 9 more people, your total would be at 14. So this column is just adding up the total number of people you've been at after you finish each section. So what we can do with that data is we can plot points. So the way that you're going to plot points is at 10 it was 1. So at the end of the class, you plot the total number of students. Okay? So at the end of, from 10 to 20, our cumulative frequency was 5. So at the end of 20, we plot 5. Cumulative frequency after 30 was 14. So at the end of 30, we plot 14. So I'll give you some time to plot the points, put your scales on there, okay, and I really want you to focus on getting these points in their proper spots. So we've plotted the points at the end of each section. And so something happens, for example, let's look at a section between 40 and 50 where there was a big gap. Okay? At the end of 40, we had 26 students. At the end of 50, I think there was 58 students. So there's a big gap. And after plotting these points, you draw a nice smooth curve through all of those points. What you get is a nice way to estimate things in between. So for example, if you were going to wonder, and in this case, one of the things that we're going to wonder is the median. Now, if there was 100 students, the median would be the 50.5, or the average of the 50th and the 51st one. But if we go across from 50 and hit a point and go straight down, it looks like about 40, 47. So we can say an estimate for the median is approximately 47 based on this data. Now, if you just looked at your chart, all you could say is we know the median class is going to be between 40 and 50, and that the median is somewhere in there. Using this frequency curve, we actually can come up with a much more accurate result of what that median should be. Same thing, we can look at 75 and 25 and get estimates for quartile 1 and quartile 3, and an estimate for the interquartile range. I have to admit, I have used this outside of school. So someone was writing a contest, or they were writing a practice contest. In my case, they were writing a contest that had been done in the past. So the results already were known across Canada, how students did on that contest. Of course, the student that was writing the contest didn't have the answer key, so they couldn't cheat or anything. They couldn't actually enter that contest because it happened 4 years ago. But they wrote the contest and they said, how did I do? And I said, well, here's your score, and here's the average that year, so you were above average, but do you want to know really how well you did? Like, was I in the top 10%? Was I in the top 20%? And so the students score, ended up being somewhere, just draw a line, let's say it was right here. So I could go on the cumulative frequency and figure out where they were percentage-wise out of the total group. So what you could do, let's say you're going to university and you're like, okay, I'm preparing, going to US University, I'll have to write SATs or something. You could pick an old SAT where you haven't seen the answers, do it, see how you did, and then look at the results from that year. And this would be one way you could compare how you would have done had you written it that year. Yes? The red dotted lines that were on here were to help us find the median and quartile 1 and quartile 3. They were based on the total cumulative frequency, which is 100 in this case. So the median is the 50th percentile, or the middle. So out of 100 students, technically the median would be between 50 and 51, but we're estimating, so 50 would be accepted as fine. Quartile 3 is 75%. It happens to be perfectly at 75. If the total number had changed, let's say this total number was 60. If I wanted to find the median, what number would I go to go across from? About 30. 3/4 of 60, I would go across at 45. So you're finding out the 25th percentile, which is quartile 1, the 50th percentile, which is the median, and the 75th percentile, which is quartile 3. We don't often use the word deciles, but we do hear the word percentiles quite a bit. Your parents probably heard a lot about percentiles, especially when you were little. It seems to be the thing to do. They go in when you're 2 months old and you get weighed and you're like, ooh, what a fat baby, you're in the top 5. You're in the 5th percentile. Or, oh, he's really tall, really long for his age at 2 months. And they have all that data and the doctors give you that data right away. Nobody goes now for your local checkup and finds out, oh, what percentile you're in now. It doesn't seem to be. But when you're little, it seems to be such a big deal to find out how big you are. So I'll let you fill in this cumulative frequency graph chart on your own. Now, in this time, I wrote above this cumulative frequency polygon. If you drew a cumulative frequency curve, that's perfectly fine. The difference between a cumulative frequency curve and a cumulative frequency polygon, the polygon one just does a straight line when it joins them. I like the curve better, but it gets a little bit bumpy along the way. Then from this, could you estimate the mean, median, upper and lower quartiles? Well, the median would be at 20 since we have 40 students. Technically, it would be at 20.5. But for an estimate, 20 is fine. So according to my graph, I got quartile 1 to be 14, quartile 3 to be 40, interquartile range to be 26. Were your numbers similar? Close? And so you can see we're estimating here. And this is part of the, like most of you have done pre-calculus all the way through. You're getting used to being exact. And this kind of feels a little bit wishy-washy, right? Because depending on how you drew your curve or the scale that you drew your curve, your numbers are going to be slightly different. But we are getting an estimate here. And the estimate itself is actually fairly accurate, but it is still an estimate. So that can sometimes feel a little funny in that regards because you're used to having things exact. And so if the Cricket Club wanted to award prizes to the top 20%, the top 20% would be the 80th percentile. Okay, because 20% of 40 is 8. If we go to our curve now and say, where is the 32nd person? And that's where that green line is drawn across. Mine came out to approximately a score of 44. So the 80th percentile, 30 was the 75th percentile, that's quartile 3. The 80th percentile would be person 32 out of 40. And then going over from 32 and then going down to the score, it came up as 44. So that could be, we're going to use 44 as our minimum this year. And it might be that when they actually go to hand out their awards, it might not be exactly 8 people that get that award. Not perfectly the top 20% because of the way that they have their data. But it becomes an estimate for what they should use, and it's fairly accurate. Oops. Example 3, of course, did it go? Here's 4. There we go. Example 3. I can go back to D for a second if it didn't disappear on me. I think this. So example 3, you've got this graph already, okay? But on the graph, clearly mark in the same way and write down the value of the median and the upper quartile. So we can look from the data and notice from the end of your cumulative frequency curve that the final point is at 80. So that means the total number of snail shells is 80 from the curve. It's also given to us to be 80 in the question. So if I want to find the median, I'd have to go across from 40, technically average of 40 and 41, but for estimate purposes, that's going to be good enough. And for the upper quartile, go across from 60. Getting those values, we get 20 and 24. This is more typical of what kind of question you're going to get on an IB exam using cumulative frequency curves. Because drawing a cumulative frequency curve on your exam is time consuming. And everything is really time sensitive on your exam. So they could ask you to draw it, but they can't give you enough marks for the amount of time that it would take. So instead, most of your exam questions go, the curve's been drawn, or just draw a little bit of it, or just fill out the chart. Something more simplistic that way. And then from that, can you figure out these questions? Yes?
So would that apply for a test as well?
Yes, for the most part. Although on a test, since we do have a little bit more time, we can ask you to draw one. But generally speaking, you're going to get questions like number 3, where you've got the graph and you plug in the information. Or you've got the graph and you have to fill in information that's missing. And that's what example 4 is like. Example 4 is filling in information that's missing. So now that you've had a little bit of time to work with these, see if you can analyze the graph in question 4 and the chart and fill in what's needed. Yes?
We have to use approximation signs.
Yes, I should have used approximation signs here, because it is just an approximation. Yes?
Like how often
In questions like this, because they give you the grid, what will happen is 40 matched up perfectly coming down to 20. Okay? And so sometimes they allow a little discrepancy, but if they make the chart themselves, and from the chart everything lines up, then they're looking for those numbers exactly. Okay, a little check of how you did. Find out that those numbers were 11 and 14. Going across from 40 and down, your median should be 32. Going across from 16, across from 20 and down, you find quartile 3 to be 40, quartile 1 to be 22. And your interquartile range, again, we could use approximation signs here. Of all the places that they're lenient, if there's such a thing with, I don't know if it's an oxymoron to say IB and lenient in the same sentence, but with the cumulative frequency curves, had you put an equal sign in some of these places, that is a place that they do not, on the final exam in their marking guide, they're not like deducting a mark for that. So, because some students will just write 32. Well, that's the right answer, that's the exact answer they're looking for. I didn't put an approximation sign in front, they're not going to deduct for that. I know that in most places they're extra picky. It's nice to hear in some places they have some leniency. Okay, I'll get you to try this one on your own as well. Here's our test mark out of 100, written by 800 students. I would love to mark that. It was probably multiple choice that they could run through some sort of scanner. And there are the different marks that different people got according to the cumulative frequency graph. How many scored 40 marks or less? So now we're coming from our diagram looking at 40 going up, and we get an approximation of 100 students. And here is the first time that we get this kind of wording. Does it make sense that the middle 50% is your interquartile range? Okay? And they used a nice number. I've seen on exams where they do stuff like the middle 30%. So then you have to think a little bit, well, what percentiles are the middle 30%? Well, I'd have to go up 15 from 50 and down 15 from 50. So I'd be looking at from 35 to 65 would be the middle 30%. So sometimes it gets more complicated and they make you think about what your data means. So the middle 50%, you would look at student 200, that's quartile 1, student 600, that's quartile 3. And so A would be 55 and B would be 75. So if I have all my data, and I just want to look at the 50% in the middle, that would mean that there would be 25% above and 25% below. And if I translate that into quartiles, well, 25% below that first number would be my first quartile. And then if I would go up 50% from that first quartile, I'd be at my third quartile. Or at the 25%, from the 25% to the 75% would be the middle 50%. Often what I do with these middle kind of questions, so if I said, where is the middle 40%? What percentiles is the middle 40%? be from the 30th percentile to the 70th percentile. So what I do with that 40%, if I want to find the middle 40%, I cut that 40% in half and say that means there's going to be 20% above the middle, 20% below the middle. So if the middle's at 50, 20% above would be my 70th percentile, 20% below would be my 30th percentile. Same thing happened here. For the middle 50%, 25% above would be my 75th percentile, 25% below would be my 25th percentile. Where do those numbers show up? Well, we had 800 students in total. 25% of 800 is 200. 75% of 800 is 600. Bunch of data on there. Write down the median. If you would go across from 60 and down, you get approximately 165. For your interquartile range, 25% would be at 30, 75% would be at 90. Those two values are 170 and 160. So your interquartile range is approximately 10. Given that 60% of the girls are taller than A, so 60% of 120 is 72, but I don't go across from 72 because that means 72 are taller than A. That means 72 are in the upper half, and the other, in this case it would be 38, would be in the lower part. So this is really what we're looking to put on here is our 40th percentile, which is at, 48, not 38. Go across from 48 and down, and we get that A is approximately 163. And then we got one more to try. So if you're working on it later and you wanted to check your answers afterwards, it will be up here. Less than 5 minutes, so you go up from 5 and over. Between 5 and 7, so you go up from 7 and over. The median time, since there is 150 students, you go across from 75 and down and approximate it to be 6.2. %40 of the people spent longer than K minutes. So this would be the 60th percentile. Does that make sense? If you want the top 40%, that's your 60th percentile. So this time I calculated the number directly to be 90, and then I went for my chart and got an approximation. Oh, no, keep it at 38. It's probably...
The chart.
Yours says 38 here? Yeah, it should be 40. I think that's just if you actually look at the data points while you're going on there, it works out better to be at 40. So you would get that data from your cumulative frequency graph and calculate an estimate for the mean. Well, this is a review question where you take the midpoints of each one and put them in. Either you could do this with this formula, or you could type in list 1, all the midpoints, list 2, all the frequencies, and get it from your calculator as well.